Well, hello again, everybody. Nice to see you. Hope you're feeling well. You sure look good today. Today, we're going to take those motion graphs that we've been working on that nobody probably likes anymore, and we're going to get some equations from them. So, good news is this. You have made it. This is all the rest of the new stuff on motion graphs. So, congratulations. Well done. Um, just one thing today. We're going to talk about some equations we use where the equations we use come from. Um, it's good to kind of get this. You will not have to derive any of these from anything, but you do really need to kind of have a gut sense of where they come from. The other thing you're going to need, and you're going to need it on WebAssigns from now until forever, is your equation sheets. And the one we're going to do has two columns. The top one on the left says Newtonian mechanics, on the right electricity and magnetism. We're going to be starting up on the left side there. So go ahead and grab that before you move on. And here we go. All right, so from last time, what we had was if we had a constant positive acceleration, we knew that the graph for our velocity had a positive slope. We're not sure exactly where that graph was, up, down, middle of the graph, whatever. We knew the slope was positive. All right? If the acceleration was 0, we knew that the slope was 0. Okay? And if our acceleration was negative, we had a negative slope. All right? I'm going to jump back up two slides. All right? Positive slope means we're tipped that way. 0 slope means we're flat. We might be flat up there or down there. And negative slope means we're tipped down somehow. All right? Hope you remember that. Now, here we go for the new stuff. All right. In general, okay, I'm going to put on here we have a positive slope. I'm sorry, a positive acceleration. So we have a line somewhere up there. Now, we're not sure where, okay, but we know that's going to tip up. If we had a negative one, it would tip down. This is just what we covered, and we could also have a 0 slope. So those are our options all moshed together. Now, here's what I'm going to do. I'm going to pretend for now, just for this first time through, that we're going to have a positive slope. And I'm going to draw a line up on our velocity graph as an example, just a general example. And I'm going to draw it this way because we are most comfortable with that. Okay? All righty. Let's take a step back. Let's pretend we're back in math class. And I'm going to recopy this in what we're used to in math. Here's x, and here's y, and my line goes like that. I'm going to write an equation for that line. Okay? So here I go. Y equals mx plus b. I'm going to label everything I can on this graph. B is the y-intercept. So this is B right here. And the slope equals m. All right. How are we doing? Now, we want to take that line from our math lives, and we're gonna mosh it over into our physics world. And we're gonna come up with the same equation, y equals mx plus b, but the letters are gonna be a little different, and it's gonna be our physics letters that we're gonna use for a long time here in physics. Okay? So, here's the easy one. We're going to change the x in this equation to a t. We're going to change the y to a v. Okay? How we doing? Now, here's the crazy thing. What is the slope of that line? The one on the v curve. The slope equals a. We took that slope and we put it down on the graph as a. All right? So now we get to take this m and change it into a. All right? We only have one more thing to change. Can you see what it is? It's our b value. Well, we can see where that is on our graph. It's right there. What the heck is that? That value is the velocity when time is 0. All right? So, are you ready? Right here, time is 0, and we go up to whatever the velocity is then. So we're going to go back to the way we wrote this before. I'm going to put an arrow over to it because it's a little ways off. Sorry about that. That'll disappear in just a second. Let's go back to our regular thing, our regular color. That is v at time equals 0. Okay? So here we go. I'm going to rewrite my equation down here. Y equals mx plus b. And let's make all our substitutions. Okay? What color should we use? Let's use blue. All right. What did the y change to? The y was v. Equals is equals. What's our slope? Our slope is a. Okay. What is our x? Our x is t. And our b becomes v0. There's a lot there. How did you do? Did you hang on? Now, in our physics world, all we do one thing a little different. We write the v0 first, and we write the a times t later. So here's what you're going to see. V equals v0 plus a times t. I am going to put a huge bunch of happy faces all the way around that. That's our first equation that you need to know. Stop for just a second. Look where that came from. All that is the equation of the line on our velocity graph. On this guy right here. That's all that equation is an equation of the line that's right there. Okay? Look at your equation sheet. On the left side, where it says Newtonian mechanics, that's the first equation. Okie dokie? All right. That's all the ugly math I'm going to do. Now, what we have to do is go one more up. So, if we have a constant here in our acceleration graph, here in our velocity graph, we get v equals v0 plus a t. Guess what we're going to do? We're going to go up to the position versus time graph. And you're probably freaking out, thinking, oh my gosh, this is going to be awful. What I'm going to show you is this. I told you before that we have some kind of curve that goes up, something like this. Pretend you can see me right now. I'm going to wave my hands around. We're not going to do any math. I'm going to just give you the answer for the equation. Okay? Here we go. The equation of this curved line is x equals x0 plus v0t plus 1/2 a t squared. Now, we basically do the same thing we did before. It's just a lot longer and a lot harder, and you don't need to know it. So we're not going to do it. Okay? This, my wonderful physics friends, is number 2. There's number 1. There's number 2. All right, look on your equation sheet, and there you have it. Okie dokie. Now, I can do some more fancy math. I can take these equations, plug them in with each other, do some fancy algebra, and I will end up with the last equation for now. It's the third one on your sheet. Guess what? Fantastic news. I'm not going to do it. I'm just going to write it down. V squared equals V0 squared plus 2 times A times X minus X0. Oh my gosh, that's awful. But I'll make it all better. I'll put little smiley faces around it. There we go. Equation number 3. Look at your equation sheet, third one down. Boom, we are done. Those 3 equations you are going to probably come to hate completely very soon. So tomorrow we're going to jump in with some heavy-duty math and these equations, and we're going to hit it hard. Hope you enjoyed that. I even have some more good news for you. No video problem today. All right? Congratulations. You just got through a really hard lecture. Talk to you tomorrow. Bye-bye.